Okay, Assalamualaikum warahmatullahi wabarakatuh for everyone. My name is Muhammad Amin Ifan bin Roslan. Today, I want to present about multivariable calculus project, and I'm from group 4 from section 3. So, my part is question 1. This is our manual calculation that I have used I solved. So for the question 1 is use partial differentiation to determine the expression dy over dx in following case. So this is the equation that I have give. So this is the manual calculation that I have used. So the final answer is we will get 3x over power of 2 minus 4xy over 3y over 2 minus 2x power of 2. So compare the simulation that I have used. Maple is first for the variable is I declare as a g. So g equal to x power of 3 plus y over y power of 3 minus 2x power of 3 over y. For the blue color is for the output, the black color is for the input. After that, differentiate the depend on the x of equation. We will get the 3 power of 2, and last one implicit the equation of variable g, y and s. Will get the final answer like this. So for the another question is for the another part. So is sin power of 2x minus 5 sin x cos y plus tan y equal to 0. So for the solution is d over dx, differentiate for the all equation. Will get this 2 sin x cos x minus 5 cos y over y cos x, and then differentiate d over dx, then and also differentiate d over dy. After that, combine the differentiation, we will get this. So to compare from simulation is first declare the variable like this, and then run, we will get the answer like this. After that, differentiate like the manual calculation, d over dx to the equation, we'll get this, and then we do a Pythagoras identity. The occasion will get this, and last one we come for the differentiate the d over dy depend on tangent y, so we'll get this. After that, combine using the implicit difference f, y and x, we'll get this same as manual calculation. So the other part is equation 1b. This is the solution. We use the solution, the final answer we get 0. So for the simulation, we first I declare like this. First for the variable equation z equal to x y over x minus y, we will get this. Then differentiate the d over dx in term of z, we will get this, and also same method for the d over dy in term of z, we can, and second differentiation we do for the d over dy dx, we get this, and first we substitute the equation 4, and then minus 1y power of 2 times we substitute in equation 5, we will get this. After that, expand and simplify, we get 0. So the last one is C, differentiation determinant of x plus solution is need to draw the image of the solution like this, and the last one is solution improve the fr fx cos theta plus fy sin theta. This is solution, and last one the simulation is we'll get this. So the final answer same like the manual calculation. Okay, that's all for me for question 1. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Taluk Anwar bin Iskandar Marok. My matrix number CE210107. Okay, today I will show the question 2 for the assignment multivariable calculus. Find the volume under the surface x equal to 3x power 3 plus 3x power of 2y and over the rectangle. Okay, for the manual calculation is we use the double integral. And first we integrate the inner integral to 0 tx power of 3 plus 3x power of 2y dy equal to, and we get the answer 6x power of 3 plus cx power of 2. Okay, next we integrate the outer integral 3, 1, 6. We put the answer and we get the 243 over 2 plus 54 minus 3 over 2 plus 2, 3, 5, 1 over 2 minus 7 over 2, 3, 4, 4 over 2, and we get the answer 172. And for the manual calculation using the Simulab is same like manual calculation. We got the answer. We use the double integral. We put the 3x power of 3 plus 3x power of 2y dy dx. And first we integrate the inner and the outer integral. We integrate 3, 1, 6x power of 3 plus 6x power of 2 dx, and we got the answer 172. Okay, for the question 2, for the question B, find the surface area of the portion of the parabolic given by the equation z equal to 1 minus x power of 2 negative power of 2, that is above the xy plane. Okay, for the question B, and use the vector. First we differentiate and we get u negative u sin v, u cos v, and 0, and we put in the matrix vector. And next we use the double integral to pi 0, 1, 0, and we put the answer from the above. Square root u 4u for 2 plus 1 du dv, and the answer is for the question B is pi over 6 square root 5 pi minus 1. And using the Simulab, the answer is same with the manual calculation. And we put in the Simulab, we put in the double integral, and we get the answer same like the manual calculation, pi square root 5 pi minus 1 over 6. And for the C, question C, an ellipsoid is given by the equation 4x power of 2 plus 4y over power of 2 plus z over 2 power of 2 equal to 16. And first sketch the 3-dimensional 3D graph of ellipsoid and its projection on suitable plane. Okay, first we draw using the words. The z-axis is 0, 0, 4, the x-axis 2, 0, 0, and the y-axis is 0, 2, 0. And we use the GeoGebra. We put the equation above and we got the ellipsoid 3D graph. Okay, for the B, question C2, find the volume of the ellipsoid using triple integral. We must use the triple integral. Okay, for C2 we put the equation in this triple integral. And we put the u 16 over 4r square in this equation and find the volume using the double integration, and 2 pi 0 to 0 plus 16 over 3 d theta, and the last answer is 64 over 3 pi units. And using the Simulab calculation, the answer is same with the manual calculation. We use the triple integral and we put the equation in the triple integral, and for the last we integrate 2 pi with the 32 over 3 d theta, and we got the final answer is 64 pi over 3 units, same like the manual calculation. That's all from me, thank you.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Fuadi Dina bin Fuadi Rizal, and today I will show you for the next questions, which is question 3. And this is the first question. Find the mass of a wire in the shape of helix RT equals to cos pi I plus sin pi TJ plus 8TK. Sorry. Okay, this is for the handwriting calculations that I made. Okay, this is the area length formula, ds equals to, and this is the formula, and this is the next step to get the ds calculations. And then for the mass, this is the formula for the mass, and then we put all the value in the mass formula, and then for the final answer is the mass of the wire is 67/3 square root pi square plus 64 unit. And next is the word calculations that I made, and this is the last answer. And for the simulation, I'm using the Simulab to get the simulation of questions A. This is the what we call the questions, and this is the step that Simulab show to us, and this is the final answer. And next is for the questions B, given the force field, and we have three questions in the questions B, and this is the handwriting calculations for question 1, and this is the final answer, F equals to 0. And next is the number 2, as you can see, this is the last answer, and this is the number 3, and this is for the last answer for the question 3. And next is the word calculations. For number 1, number 2, and number 3. And next is for the simulation, still using the Simulab, but for the simulation for the number 1, I don't get it because when I try to put the equations, it shows error and don't get the step for the answer, and I'm only get for the number 2 and number 3 for using the Simulab. This is number 2. This is the final answer, and this is the number 3, and this is the final answer that we get from the Simulab. And lastly is question C, verify Green's theorem by evaluating both integrals. As we can see, this is the equations, and this is the path that along the graph of y over y equals to x3, and this is the graph, and this is the handwriting calculations that I made. Okay, this is the integrate y equals to x from 1 to 1 to 0 to 0, and this is the next step to get the answer, and I put the integrate to the formula inside this integration. And the next is the last answer is I get 1 over 12, so the Green's theorem is certified. So this is the word calculations, number 1, number 2, that's all. And lastly, for the simulation, still using the Simulab, and for the steps, and this is the equations, and this is the step from Simulab that show the step calculation, and this is the last answer from the Simulab. That's all from me. Thank you.
Assalamualaikum and hi, my name is Muhammad Hamshari Hamizan bin Muhammad Zaidi. My matrix number is CE210123, and today I want to present question 4 and question D. So for the first question A, I need to identify the word done. So this is my handwriting calculation, this is the formula. So I calculate using the formula, and let C1 be path and do some differentiate and integrate, and need to find the C2 first before I get the work done, which is the answer is 1 over 2. So this is my work calculation, same answer, because it's just I need to do the work from the rubric required. So this is my Simulab software that I use to calculate. So as we can see, the answer is same. The answer is same as the my calculation.
Hello, Assalamualaikum. My name is Ahmad Nuraina Fitrasini. My metric number CE210088. So I will continue the next part, which is for B and for C. So for B, Solve the electric flux through a parabola z equal to x squared plus y squared minus 16 that lying below length z equal to 0. It is oriented by an outward unit normal vector with f equal to 3x y vector plus 4yj vector minus z squared minus 5z squared j vector. So we use the triple integral derivation flux. So our first step, we must do like this, and after this equation we get 7 minus 9z. So next the answer we put like this for the next step, and we use cylinder coordinate, which is x equal to r cos theta, y equal to r sin theta, and z equal to z. From this coordinate we get like this, and from this equation we put like this because we must integrate the number. First step, first step is we must solve at the back first. So like this, we must differentiate 0 r square minus 16. So after we solve this, and the final answer we get this. After this, we must solve the second one, and we differentiate like this, and the final answer is here. And next we must solve at the in front, and the final answer we get this. So for the simulation, we use Simulab. We put the number here to make sure the answer is same, and we put like this, and the final answer we get same. So this is all for the question for B. And next for C, determine the flux of the vector field F equal to x by vector minus 2yz vector plus z plus 7z square j vector across point z square root x square plus y square plus 3 that lies in between the plane z equal to 4 and z equal to 8 by using the cross theorem. So first step, we do the triple integrate, and we use the cylinder coordinate system, which is x equal to r cos theta, y equal to r sin theta, and z equal to z, x squared plus y squared equal to r squared. So from this we get this, and from here we must do the equation like question for A before. So we put like this, 2 pi 0, 5 and 8 4. So first step, we must solve at the back first, and we differentiate this. After we have done the differentiate, we can get like this, and next we must solve at here. So after we differentiate this one, we get this, and the final answer, and the final we must differentiate this one. So we put like this, and the final answer is 9744 pi. So for the simulation, for the C we use MATLAB, and we get this for the final answer. So that's all from me.
Question D need to use Stokes theorem to evaluate. So this is my handwriting. The formula is this. So I calculate step by step using that what I have learned before at the class. So to find the normal, and this is to notice that this is the region in my plane, in xy plane. In xy plane, z equal to 0. The range will become this. So do some integral and get the answer this. So this is my weight calculation, and this is my MATLAB, software MATLAB. Thank you.